I think part of the problems with the explicit resource management proposal is that it doesn't address this underlying mechanic, which is that when you're awaiting a promise, if it doesn't resolve, you're stuck. And so by relying on the async await as its underlying its underlying mechanism, it's subject to this whole thing. I also think that there are problems in that it's optional. So not only can you get stuck because there's a promise that's gone rogue, but you can also get stuck because you forgot to declare something with using. And so what I would foresee is that we're going to have a new ESLint rule that is don't use const, don't use let, use using for everything, which is silly, right? Yeah. But that's the only way to enforce safe. Like, it's the only way you can be safe. And so I think the optionality is a little bit strange, and just the syntax is extremely complex. I don't even remember, but if you look at that table, you've got like for using await, for await using, const using. Like it's almost impossible to comprehend. And I think that's also touches on an adjacent problem, which is the async await resolves synchronously. The only time that it resolves asynchronously is if it's actually waiting for something. And so what that means is, unlike async await, you can use Effection for an event handler. So one of the reasons you can't use async await for an event handler is that cancellation and prevention of defaults is a synchronous operation. So even though I would say an event stream from a button, like handling clicks, is most elegantly modeled as an async iterator, you can't do it because it's going to resolve in the next tick of the run loop, and that event is gone, and you can't handle it. So as a result, we're left to do awkward workarounds, and we're back in using callback hell if you actually want to handle events well. And then there's a bunch of different problems too around caching, where if you want to check something synchronously and make sure that it's in the cache, but then you need to fetch asynchronously, being able to do that with async functions and a combination of sync functions is it's extremely vexing problem. And if you Google it, you'll see a lot of people being very frustrated about it. And then finally, it just means that every API has to be bifurcated in some weird way. So we have symbol iterator, symbol async iterator, symbol disposable, single async disposable. And so the other reason I don't like the explicit resource management is that it doubles down on this idea of there being two hermetically sealed worlds of sync and async, and you can't communicate between them. It's better than, I would say, if you're going camping in the woods and you're trying to survive, having a tarp is better than not having a tarp. But I would rather have a log cabin with a fireplace and a wood pile.
On that note, so Effection is the log cabin with the fireplace and the wood pile. Let's talk a little bit about how Effection solves this problem. And I guess maybe if you want to back up and talk about if there's like some underlying motivation of like why you built it.
Sure, I can talk about those first. Yeah. So the underlying reason that we built it is that we were working on web front ends. There was actually two projects. We were working on web front ends, and we were at that time using Ember JS. And so Ember had a structured concurrency library, and the patterns that you could do AJAX requests that were automatically canceled, whether you were closing a route, whether you were repeatedly making a request inside of an autocomplete field, or you wanted to manage, the other thing that we used for was managing like 10 concurrent uploads. But if you changed another upload, you wanted to queue it. And again, touching into the other functionalities that I just mentioned, if you exit the page or you exit the route, you want to cancel all of them. The patterns for managing the life cycle of concurrent operations were extremely elegant. I'd never really encountered anything like it. Like the amount of thought I didn't have to expend on tearing stuff down, understanding when stuff needed to just go away. And I could just say, you know what, if it's tied to this lexical scope, that's the lifetime of the task. That was my first encounter with structured concurrency. And I was like, okay, this is really something here. And then it was shortly afterwards that blog post came out, which I would encourage everyone to read. But then we ended up working on a custom testing framework that was, it itself was an orchestration server that was managing like 5 or 6 different processes. It was also managing a browser. like Playwright. It was also managing a set of simulators that would come up, and there was a ES build bundler that was also it was managing. So this was again taking the pattern from the front end over to the back end. We realized, okay, we can use this structured concurrency back here because this is just going to be a nightmare if we're trying to manage this all by hand. And so that was the very first version of Effection was a server conception of this front end framework that we had used in Ember. And as we developed it, the idea of structuring concurrency gained more traction, especially outside of the JavaScript community. And so you have, especially on mobile platforms, where, like basically Swift and Java, which are the main development languages for Android and iOS, or I should say iOS and Android, respectively. On a mobile platform, you're dealing with highly event-driven code. And so for them, it was very beneficial. And so I almost think that JavaScript is a victim of its own pioneering success in the sense that nobody had async await before JavaScript, and there really is I don't want to bash on it too much. There is a real power in having these suspendable coroutines, and they almost got the story right. But async await came out in 2013, 2014, and then structuring concurrency as an idea was formalized in 2018. So by being ahead of the curve, I feel like we've also missed the boat a little bit.
Cool. So we've talked a lot about Effection, but what does it look like in practice to use? I've looked at some of the other similar libraries in the space, and they're hard to learn. They have a big API surface, but Effect doesn't really seem to have that, or Effection.
So Effection, our fundamental stance on Effection is that the only thing you should have to learn is structured concurrency and structured effects, or in other words, resources. And everything else should be JavaScript. So people have spent a lot of time learning JavaScript. They've spent a lot of time learning JavaScript APIs. They spend a lot of time interacting with the JavaScript ecosystem. And so we want 99, if not 100% of that knowledge to be applicable to writing Effection code. So if you know how to do something in JavaScript, you're going to know how to do it in Effection. And I think that's very valuable, because if you look at Effection code, it is immediately recognizable what it is that you're trying to accomplish. And with a few substitutions, you can transition from vanilla async await to Effection and back and forth. I would say that's the primary goal there.
Yeah, I think Andrew made a little Freudian slip to this, but I think the other big library in the space is Effect. Yes. So we had Johannes Schickling on a while back, and he talked about Effect. And Effect is this amazing library, and it does a lot of things. So it tries to do structured concurrency among many things, and to me it feels like Erlang and TypeScript. It's really bringing a whole new paradigm, and it is a paradigm shift, and with all the benefits and costs that come along with that. So that's one thing that I do like about Effection, is just trying to solve this one problem. But there is some good things that Effect does, and I was wondering things about, I don't know, does Effection have a lot of opinions about error handling? So you get the errors in a way that's that has the guarantees of structured concurrency, but then you have to, what is the shape of this error or whatever? You're still responsible for doing all the other stuff, right?
Sorry, is the question about error handling and difference in error handling?
Yeah, is there any difference in error handling beyond the structured concurrency primitives?
I'm not an expert on how Effect.ts does error handling or how it encourages error handling. I will say this, that the way that you handle errors in Effection is the same way that you handle errors in JavaScript. And that's thematic of the way things work in Effection. So what you do is you put a catch block around your code, and you can catch errors. And if you want to return that error as a value, you can do that like you would in Rust or Go and maybe Effect, but it's up to you and your option. So we actually do have a result type that's not, we don't encourage you to use one or the other. My personal preference is I know there's a little bit of a backlash against exceptions. Personally, I like exceptions a lot. I think you have to be mindful of the type of code that you're writing. If you're writing framework code, then it's very appropriate to treat exceptions as values, because in framework code, you are explicitly managing the flow control of other code. And so using exception handlers or using exceptions that unwind your stack is really onerous, because you're actually explicitly dealing with routing that control flow and routing those errors. So if you look inside Effection, you'll see that we always deal with errors as a result object. And we're doing a bunch of checks like, this is okay, proceed, but we're always treating errors as return values. But if you're inside userland and 99% of the time there's nothing to be done about an exception, then why the hell am I saying anything about it? And I want to be concentrating my exception handling in a single place. And so that's the heuristic that I live by, is if I'm routing errors and the job of my code is to route errors, then treat the error as a value. If I'm not, and there's nothing I can do to recover from an error, then don't. And so that's a long way of saying is you can do both. The Effection way is that you would handle errors the way that you would just normally.
It's cool that you guys don't bake an opinion in there and like set the two features to coexist with each other. I want to dig into a little on how Effect does its stuff, I want to dig in a little bit to how Effection does all of the magic. You said it's just JavaScript, but it is using the part of JavaScript that probably 99% of people haven't interacted with, which is generators. So how do generators like help with this problem of structured concurrency in ways that Promise can't?
So let me back up so that the fundamental primitive in Effection, actually, believe it or not, is not the generator, it's the iterator. And what an Effection operation is just a iteration of effects. You're essentially using an iterator to express a coroutine that can be paused and can be resumed. And at its simplest case, what you're doing in a Effection operation is you have an iterable of effects, and you pull the effect off, you evaluate it, and when then that gives you a result, you pass it as the input to the next effect. And that's going to wave a little bit of hands here, but that's the way it works. It's the same basic process in Effect.ts. It's the same basic process in Haskell monadic evaluation. This is how you stitch together pure functions with side effects, is you basically have a list of pure functions that are interleaved with side effects, where the side effect is evaluated, and then you're passing a pure function, or passing an argument to a pure function, which then gives you your next effect. So all that said, a generator is a very clean way to express an iterator. So I like to think of them as coroutines. So it is actually very similar to an async function in the sense that the state of the function can be paused at your yield points, which is the same as an await point inside of an async function. And then when the effect resolves, you can pass that value back to the coroutine. And as a matter of fact, generators predate async await. So they've been part of JavaScript for a much longer time than the async await has. And furthermore, the async await was originally built using generators, because the generators are general purpose coroutines. And what that means, amongst other things, is that because this is the primary way that you express these iterators, Effection is with generators, you are able to express a general level of effect with your yield than you can with an await, because an await is basically a special case of a coroutine resumption that is only this. It's an effect that can only track promise resolution or promise settlement, whereas at a yield point, there's an infinite number of effects that could be resolved. And so you see this actually in Effection. Not everything is an asynchronous operation. Sometimes what we're doing is we're getting something off the context, and that's a synchronous effect, but it's a similar idea. So it's actually infinitely more powerful in a way. So it predates. It's actually simpler than async await, and it's many orders of magnitude more powerful. But this is actually something we try and point out a lot. It's just JavaScript. Every browser runtime supports it. You don't need any build tooling. It's all built in, and it's really fast.